Hello, Science 14. And today we're going to be talking about mixtures and their uses. So we started talking about matter, and matter was broken up into pure substances or mixtures. With our pure substances, we looked at elements of the periodic table, and we also looked at compounds when we had two or more elements come together to make a compound. Now we're going to talk about, on the other side, mixtures. So if you don't have a pure substance, you have a mixture. And mixtures can either be mechanical mixtures or solutions. Sometimes we call these heterogeneous and homogeneous. So mechanical mixtures would be heterogeneous and solutions would be homogeneous. So a mechanical mixture is something that you can see more than one type of particle. So you can see more than one type of particle in this mixture. And an example is salsa or a chocolate chip cookie where you can see all the little chocolate chips in the cookie. So you can see that there's more than one thing making up that mixture. Another example could be a smoothie, where you can see all the different parts in the smoothie, or even orange juice, where you can see all the pulp pieces floating around in the orange juice. So if you put a mechanical mixture through a filter, something is going to get caught in that filter. That's how you can tell it's a mechanical mixture. Now we also have solutions. And solutions are when two or more substances combine to form a mixture that all looks like it contains only one particle. So it looks all the same. So if you look at your shampoo, it just looks like all one consistent thing. Or your dishwashing detergent. Or maybe you made yourself some lemonade. That's also a solution. Or even the air that you breathe is a solution. So if you put a solution through a filter, nothing's going to get caught in that filter. It's just going to go all the way through. So air, even though it's a gas, it's also a solution. Now we have different parts of solutions. So solutions consist of two parts. The first part is called a solute. And this is the substance that dissolves. Okay, the solute dissolves. Then we have a solvent. And that is a substance in which the solute dissolves into. So there's usually less solute than solvent. So if I can show you in this picture here. So here I have solute. So I have this green solute. And there's less of it, because usually there's less of it. So this solute could be anything like salt, sugar, those types of things. And we're going to put this solute, we're going to put it into our solvent. And usually there's more solvent than solute. So we're going to put our solute into our solvent, and then voila, here we go. We get our solution. So here's another picture for you. Here I have a solvent that, these are two liquids now. So I'm going to put, liquid. So I'm going to put this liquid solute into my liquid solvent. And voila, I get a solution. So solute into solvent gives me a solution. And you know how I remember solute is the smaller thing? It's a shorter word. So solute is a shorter word, which means there's usually less of it. So that's my solute. There's usually less of it. It's a shorter word. And that goes into a solvent. Which is my larger word. And there's usually more of it. So more of it, that equals a solution. So we're going to keep going. So here's a learning check for us. So number 1, classify each of the following as a mechanical mixture or a solution. A, concrete. What do you think? Is it a mixture or a solution? B, shampoo. What do you think? Mixture or a solution? C, air. Mechanical mixture or a solution? D, tap water. Mechanical mixture or a solution? E, cookie dough. Cookie dough. Mechanical mixture or a solution? Number 2, what 2 tests can tell us if a mixture is a solution or a mechanical mixture? What do you think? What 2 tests can tell us if a mixture is a solution or a mechanical mixture? Number 3, identify the solute and the solvent in each of the following solutions. So salt water. What is my solute and what is my solvent? Baking soda and water. Which is my solute? Which is my solvent? Air. There's a tricky one. So I have 78% nitrogen, 22% oxygen, and then the rest is all other gases. So air, which of those gases is my solute? And which are my solvent? D, gold jewelry. Gold jewelry is made up of 90% gold and 10% silver. Couldn't all be gold or else it'd be too malleable. So which one is my solute? And which one is my solvent? Let's keep going. What are solubility and concentration? So concentration is the amount of solute in a solution. So however much salt was in my water would tell me what the concentration is. Concentrated solutions contain a lot of solute. So if I have a lot of solute in a solution, it's called a concentrated solution. Diluted solutions contain less solute. So if I have less solute, or less salt, let's say, in my solution, it's called a dilute solution. Solubility is how easily a solute will dissolve in a solvent. So how easy a solute will dissolve into a solvent and become a solution where you can't see any of the solute or any of the solvent anymore. It just looks like one solution. Soluble means a solute will dissolve in a solvent. So salt is soluble in water. Whereas insoluble means a solute will not dissolve in a solvent. That's like oil in water. So oil is not soluble. In water. It's insoluble. Okay, we're going to talk a little bit about soap. So how does soap work? Soap is a molecule with 2 ends. One is soluble in water, but not in greasy dirt, and the other end is soluble in greasy dirt, but not in water, which is genius. So a soap molecule has 2 ends. One likes water, and one likes greasy dirt. The soap molecules line up with the soluble end of the dirt and dissolve the dirt into small pieces. The other end of the soap molecule dissolves these pieces into the water, and off they go down the drain. Let's watch a quick video to understand that a bit better. Okay, so hopefully that made sense. So that shows us that soap has a water liking and a water not liking part to it. So a hydrophobic and a hydrophilic end is what it's called. Okay, so there are ways to separate mixtures. So how do we separate substances from a mixture? So we have a couple different ways. We can use mechanical removal, we can use filtration, distillation, and crystallization. So mechanical removal is when we actually physically can just remove the pieces. So for example, you could remove M&Ms, your beautiful M&Ms, from trail mix. That would be an example of mechanical removal, just taking those guys out. Filtering is when we use a filtering device or sift or filter paper to actually filter out a substance. So we could filter out sand with a colander out of water, or we could filter out coffee grains using a coffee filter. Distillation is when we actually heat up a mixture to remove the evaporated substance. So for example, we could heat up water in a pot and all the water would evaporate, and let's say it was salt water, and then all the little salt would be left at the bottom of the pot and all the water would evaporate out. That would be like distillation. Crystallization is when we remove a substance by creating crystals. So for example, we could have a borax and water solution, and we could actually make borax crystals or crystallize the borax, and we will actually be doing that in class. So now your job is to complete your assignment sheet numbers 1 to 24. So we talked about separating mixtures, we talked about how soap works, what solubility and concentration are. We also talked about parts of a solution, solutions, and mechanical mixtures. All right, that's it. Thanks for watching.